Alright, today we're continuing with section 6.7. We're going to learn about radians. This is probably something completely new to you. A radian is a way to measure an angle. So up until now we've only measured in degrees. Well, when you take some more advanced math in trigonometry, calculus, physics, they all use radian measures instead of degrees. So we're going to introduce radians to you today. First, the definition. A radian is the measure of a central angle whose intercepted arc is equal to the circle's radius. Let's examine the diagram here. The diagram represents the definition. We have a circle with radius r. That radius obviously has a specific length. If we take that length, r, and lay it on the circle, arc AB has the same length as the radius. That means that the angle measure, there's our theta for angle, is 1 radian. We're going to explore radians here. The question we're going to answer is how many radians are in a circle? You have a piece of yarn on your desk to measure with. Work through the 6 steps that you see here very carefully, very accurately, and see how many radians are in a circle. Alright, so after the investigation, we have our approximations of the number of radians in a circle. This diagram displays the process we went through, right? Measuring the radius of the circle, and then laying that radius on the circle. 1, 2, 3, 4, 5, 6, and then we have some left over, right? So about 6.25. In fact, it's about 6.28. So you have discovered that there are approximately 6.28 radians in a circle. In fact, there are exactly 2 pi radians in one circle. This means that there are pi radians in a half a circle. Therefore, 180 degrees equals pi. And we will use this conversion to convert degrees to radians and vice versa. Alright, so we're going to put our new conversion to use. We're going to convert the following degree measures to radians. And we're going to do this by using dimensional analysis. We all know what dimensional analysis is. We use it in science a lot to convert units. We're going to do it here with degrees. So 30 degrees, we multiply by our new conversion. We want degrees in the denominator so it will cancel out, and we want radians in the numerator. Now when we multiply through, degrees cancel out, leaving us with 30 pi over 180. Well, 30 over 180 reduces to 1/6, so we end up with pi over 6 radians. 45 degrees times pi over 180 gives me 45 pi over 180. I can reduce 45 over 180 to 1/4, or pi over 4 radians. 60 degrees times pi over 180 is equal to 60 pi over 180, which can reduce to 1/3, or pi over 3 radians. And of course, 90 degrees times pi over 180 90 pi over 180. Simplify to pi over 2 radians. So we've taken some very common angle measures and converted them to radians. Now let's take a closer look. With our conversion of those common angles to radians, we can go all the way around the unit circle. Pay close attention. We start at 0, 0, meaning 0 degrees and 0 radians. Now let's go in increments of 30 degrees. There's 30 degrees, and we just calculated that 30 degrees is pi over 6. Let's go another 30 degrees to 60 degrees. Now we can think of this as an increment of 30 degrees, or an increment of pi over 6. This would be 2 pi over 6. But 2 pi over 6 reduces to pi over 3. Let's go another 30 degrees to 90. This would be 3 pi over 6. But 3 pi over 6 reduces to pi over 2. Let's go another 30 degrees to 120. This would be 4 pi over 6. Because 4 pi over 6 reduces to 2 pi over 3. Another 30 degrees, 5 pi over 6. Doesn't reduce. Another 30 degrees, 6 pi over 6, which is just pi. Another 30 degrees, 7 pi over 6. Another 30, 8 pi over 6, which reduces to 4 pi over 3. 270 is 9 pi over 6, or 3 pi over 2. Another 30 degrees to 300 gives me 10 pi over 6, which reduces to 5 pi over 3. Another 30 degrees is 11 pi over 6, which doesn't reduce. And finally, we end up back where we started. 360 degrees is 6 pi over 6, or 2 pi. We can do the same thing with 45 degree increments. We calculated that 45 degrees is pi over 4. If we go 45 more degrees to 90, that's 2 pi over 4, which reduces to pi over 2 again. Go another 90 degrees to 135, we get 3 pi over 4. Then 4 pi over 4, which is just pi. Then 5 pi over 4. Then 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And 8 pi over 4, which reduces to 2 pi. So converting those degrees to radians allows us to come up with a whole bunch of different angles around what we call the unit circle.